Hello, this is Patrick with Royas, and welcome to episode 10. So in the last episode, we finished the core functionality of our network object and network managers with adding spawning. So now let's get on to actually showing you how to use this library a little bit. In this episode, I'm going to teach you how to split your code between server and client, and that way you can keep your stuff nice and separated and easy to use, and it all in one project. You don't need multiple projects. Some people online were saying you need multiple projects. You don't. So I'm going to show you how to do that in this episode. First thing I am going to do is go to scripts and create a new one, new script, and I'm going to go inherit from network object, and I am going to call this character network. Go into the scripts folder, yes, and create. Okay, let's open this up. Now I am going to go and make a class name, character network. So now this class has all the functionality of a network object but it's like super clean. And this is all the code in here. We don't really need to pay attention to the network object code because this is all we need. So I'm going to delete this process function. And at the top, I'm going to make an export. Export var spawn. Actually, I'm not going to do this one. Spawn client on server, and this will be of type bool, and we'll set this equal to false. So if this is set to true, we will have both the client and the server code running on the server. So that way you can use this if like the server is also a player, and then everything will still work. And then I'll do an on ready var my body, and this will be of type player character body. And I haven't made this class yet, so I'm going to go do that right now. At the top here, we are going to go class name. What did I call it here? Player character body. Okay, going to do that. And boom, easy. Okay, and then I'm going to go get node. And then it's going to be, what did I name this? On the scenes. I named it character body 3D. So I'm just going to copy that, go back to the script, and put that right there. Cool. Now that's done for the decorator stuff is done. Now we're going to make a signal on player input PC, and then I'm going to take in a what's args. I'm going to say args gray origin. Oh wait, no. This is a signal. I can actually do this nicely. Gray origin. Wow, I cannot spell. Vector 3. And then gray end. And this will be a vector 3 as well. Cool. Then I'll make another signal on target. And this is going to be a target and of type vector 3. Okay. Now, in this ready function, I'm just going to make a on network ready. See, as you can see, this is part of our network object, and we have access to it right here. Super nice. Then we can go .connect, and we will then go down here and make our function. So we'll say func on network ready, boom, just like that, and we will pass. And then we'll put this in here, and then after we connect to our signals, we are going to call super. So if you go to our network object, you can see that we have this logic in our ready function. Well, since we extended the network object here, our ready function overwrites all this logic in our network object. But if we call super, that means that it does everything in there. If we put super here, that means everything in this ready function happens before this on network ready. And if we put it down here, it happens after. I have tested and I have found with this, it tends to work better after rather than before, because when the server starts up, it starts up too quickly. And this gets called before it even has a chance to connect. So on network ready gets called before it even gets to this line. So it gets to this line, stuff happens, on network ready gets called, boom, it happens here. So put it at the bottom. Simple enough. Now we're going to do our on network ready function. We're just going to print so that we know on network ready. Yay. Now we're going to say if network manager dot is server. Isn't this nice that we have all this code done for us and you don't have to see it? All right. Var server script is going to be equal to null for now. And then we'll say, let's go here, actually, and then add child server script. If spawn client on server, we are going to do var client script is equal to null for now. We'll fill these out later, and you'll see why. Then add child client script. Okay, then below this, we will say else var client script is equal to null still, since we haven't made it yet, and we'll go add child client script. Okay, so what are we doing here? We are going to split our logic, so our server logic is going to live in this server script that we're about to make, and our client logic is going to live in this client script that we're about to make. So if it's the server, we're going to obviously want to spawn the server one, but if we've said that we also want to spawn the client on the server, then we do that as well. And if it's not the server, then we just spawn the client. Makes sense to me. Now let's go and create those scripts. Okay, so let's make the server one first. Script. This will be just a regular old script, and we'll just call this server, character server. Okay, character server. We're just going to click create, and then we are going to go and create new script character client. Done. Now we'll open these up. Back. Okay, now for the character server script, we'll go class name character server, and then the character client, we'll go class name, and then character client. Okay, now let's go back to our character network script that we've made. And so the server script will be character server dot new, and then the character client will be character client dot new. And I'm going to copy this, paste it here. Okay, there we go. And now let's finish this script. We're working on the character network, and then we'll go and build these scripts out. Now let's go at RPC Annie here, and we will do all local. And then unreliable, our first time using unreliable in this series. And this is just going to be our sending input to the server. So we'll go func send input array. And we will send the array origin of type vector3. And then we'll send the array end. And this will be of type vector3. Now we'll go if network manager dot multiplayer dot get remote sender ID does not equal owner ID, we will return, since we don't want to send or receive inputs from people who don't own this game object. Then we'll go on player network input received, we will emit, and then we will emit the array origin and array end. There we go. And now we will do the RPC authority all local, and once again unreliable. Because when you're sending inputs, performance is key and unreliable is faster. So we'll go func set target, and this will be target vector 3. And we'll say on target received dot emit target. Cool. There we go. Now that is our character network script done. This is all the specialized net code that we're going to do. Much, much cleaner than looking at this network object script that is 123 lines long. Much nicer to look at, much nicer to work in. Now let's go to our character client script, and we'll go at on ready var camera. This is of type packed scene, and we will do preload res // scenes / object. There we go. There's the camera. We will preload that. We will on ready again var cursor dot, and this will be of type packed scene again. Packed scene. We'll preload res // scenes / objects and cursor dot. There we go. Now final on ready, we'll do at on ready character network. Oh, whoops. Var character network will be of type character network, and we'll do get parent. Now down here, we'll go var my camera is of type camera 3D. We'll do var my body is of type player character body, and we'll do var current cursor dot. And this will be of mesh instance 3D, and we'll set this to null by default. Now, in this ready function, we'll just say print spawning client script sent character network dot owner ID. There we go. Just so that we know that's working. I will go character network dot on ownership change. These are all the signals we've created, so let's connect to them. Connect. So that's the on ownership change. Now we'll do character network dot on target received dot connect. We'll go my body is equal to character network dot my body. We'll say if not is instance valid my body, then we're just going to return. We should throw an error here, but we will just because we're lazy. Okay, now we'll go my body dot navigation agent dot navigation finished dot connect. Cool. And we'll say if not character network dot is owner, we will return once again. Now we'll spawn our camera. So we'll go my camera is equal to camera dot instantiate and my body dot add child my camera. There we go. Now let's go to our character body script and tear out this whole input function. This only needs to be on the character client, so why not, right? Put it in here. We can get rid of this. We'll go character network actually dot is owner. There we go. We'll go my body here dot get world 3D. Fix that. And here we will go my body dot set movement target intersection dot position. So we'll start moving here before on the client before we even know that the server has validated us. We'll predict that it'll accept it. Okay, now that's our input function done. We'll go function on ownership changed. We'll go old owner int new owner int. We'll say if new owner equal to character network network manager network ID. My camera is equal to camera dot instantiate add child my camera. So if someone gives you this player, you'll get the camera too. You'll spawn your camera and do everything correctly. Oh, I should do the child in the camera to my body, shouldn't I? Is that what I did up here? Yeah, I did. Let's do that here. Oops, almost put that up. Elif old owner is equal to character network dot network manager dot network ID. So if we used to be the owner, we will get rid of our camera. So we'll go my camera dot q3 and my camera is equal to null. Okay, so that's our on ownership changed function done. But you see why we're doing this, right? It makes sense that if we become the owner, we want to add the camera to this object. If we lose the ownership of it, we want to get rid of our camera. Fair enough. I'm not going to do that, but just in case. Now we'll go function on arrived at target. We'll go if current cursor dot is not null. We will go current cursor dot q3 and current cursor dot is equal to null. So there we go. We've got our arrived at target. Now we'll go function on target received. We'll go target vector 3. This will my body set movement target. Okay, let's go connect these. So we'll do the ownership changed on ownership changed. Boom. Right there. That arrived at target. Boom. Right there. I think I put that in the wrong one. Yes, this is an arrived at target. Okay. And this is target received right here. Glad I caught that. Okay, so this is all our logic that we need on our client. Done. Now let's go and change some things in the character body. So we don't need any connection to the network manager there. We don't need to get the network object at all. We don't need to see if the network is ready. We don't need this RPC. We don't need this check here. And there we go. Oh, I think we can actually get rid of this check too. Here we go. We're good. Our character body is good. Our character client is good. Now we need to make our character server. Okay, for our character server, we'll go at on ready var character network. And this will be a type of character network. We'll get parents. We'll go var my body player character body. And in our ready function, we can actually get rid of this process function. In our ready function, we can go character network dot on player input receive dot connect. Yay, another connect. We'll go function on layer input origin, and this will be of type vector 3. We'll end type vector 3. How special. Now we'll go var base state equal to my body dot get world 3D dot direct space state var intersection is equal to base state dot intersect array, and in this intersect array we will physics array query parameters 3D dot create origin end. And since we are not doing any validation on this server yet, next episode we'll do some validation. We'll go if not intersection dot is empty, we'll just go character network dot set target dot rpc intersection dot position. Now we'll connect this, and I'll go my body is equal to character network dot my body, and now our server is done. So you can see we have our character network class, which handles all of the logic that we need specifically for networking. There's no RPCs in the client or in the server, not a single RPC, and we're calling these signals to emit all the data we need so that we can tie into those in the character server or the character client and do all the logic that we need there. This splits up our code nicely, and then our character body just contains everything that we need on both of them. Oh, I can also get rid of this network object. There we go. Now let's build and run this, and we've got an issue. What's the issue? Can you guess? It's the classic, I need to fix these scenes. These are regular old network objects now. I need to get this character network here. Spawn on client, I'm going to set to true. Girl 2, same thing. Character network, spawn client is equal to true, and the guys will be the same. Okay, welcome back. Let's try it again. Host, spawn, woo, it's working. Connect, spawn, yes, it's working. And we're back to where we were before, seemingly. But now, if we go to our project and export, we can just go, let's say Windows Desktop. So we can go to resources, export mode, export all resources in the project except resources checked below. Let's go up, close the assets, close the scenes, and in the scripts, we can just not do this. We can just check it and it won't be included in the build, and so then our clients never receive the character server.gd. So we can have a bunch of our safety checks and stuff in there, and they'll never get their hands on it, making our game more secure. All right. Thank you guys for watching. I hope you found this useful, and I hope this lets you know a little bit more about how to think about using this library that we've built together over the course of this series. In the next episode, I'm going to teach you how to use the validator system that we've built, and then that'll be it for at least the early testing of this series. Thanks for watching, guys. Bye.